Okay, I think this is working. Yes, I see the little record icon on the bottom. All right, fingers crossed. And fingers crossed that it's recording audio too. I guess we'll find out. All righty, so I'm going to do, I think it's number 7 on your sheet, and we'll sort of walk our way through this. 216 equals 4m raised to the 3/2 power. Now, before we continue, do we even remember what fractional exponents, what's the deal with them? Okay, so let's rewind. So side note, if I asked you what 8 to the, let's do 2/3 power. Obviously, I know you all know what 8 squared means, right? But 8 to the 2/3. Go ahead, DJ. I'm going to call out whoever has their nose covered. I should do that. Yours is, DJ. Thank you. All right, now tell me. Go ahead.
So it's like, so I don't want to take that and put it under the square root or a cube root and then like square it inside of it.
So what would your answer to that be? It is 4.
Because it's the cube root of 8 squared.
Yes. So when you have a fractional exponent, whatever the denominator is, that's actually whatever root you're going to take. So if it's a 3, we're going to do a cube root. If it were a 2, we do a square root. If it were a 4, we do the 4th root. Okay, so the denominator tells you take this root. And that's really, it's smarter to do that step first. Because you could square 8 and then take the cube root, but now your numbers are getting too big, right? So if you do the cube root of 8, that's easy, it's small numbers. So take this root first. Okay, so that really means to take the cube root of 8, and then I'm going to go ahead and square that answer. Okay, so then whatever the numerator is, that's sort of my second step, and I'm just going to raise that answer to that power. So that's where we're getting 4 from, because the cube root of 8 is 2, and 2 squared is just 4. Okay, does that ring a bell now that you see it? Do you kind of remember this? You said no? We'll try one more. Let's do... Oh, it's okay. I want to do one more anyway. What if we did something like -27, and we did that to the, let's do that to the 4/3 power. So think about what that means. You're really going to start with the denominator. You take that root of -27 and then raise it to the numerator. So see if you can come up with this. Okay, hold on to it for 1 second. All right, Braylon, what's your answer?
81.
Cedric, do you agree? Jake, you agree? You're right if you're taking an even root, but you could have an odd or a negative odd root, right? Because -3 times -3 times -3, doesn't that get you -27? Yeah, so you can have negatives when it's an odd denominator. If it were even, yeah, we'd be stuck and we'd have to go into imaginary numbers. No one likes that. But I can have, you're right. Yep, it is 81. So cube root. So again, sometimes it's helpful to rewrite it. Cube root of 27. And then whatever that answer is, I'm going to raise it to the 4th. So, oh, -27, sorry. I dropped that off. So yes, I do get a -3 in there because -3 times -3 times -3 really is -27, right? And now I just have to raise that to the 4th power. which is a lot easier if you just do 3 times 3 and then 3 times 3, and then you get 9s and then multiply the 9s together. 81. Positive, right? Okay, so there is a very quick refresher on what fractional exponents even are and kind of how they work. So now, if we take a look at something like number 7, that's a great question. So I want to solve for m, right? Just like normal. I could rewrite this using radical notation, but it's actually not going to help me any. Let me ask you this question. When we have like x squared in an equation, don't I usually take the square root to get rid of it? Like to undo squaring something, I square root it. So Cedric, you have a thought?
Can't you undo the right side by doing the opposite?
How? Yeah, you're right.
So
But
like the 216, you can put that over 2/3.
yes,
Yeah.
you're right there.
Yeah.
You are going to, if you want to undo a fractional exponent, you can raise it to the reciprocal power.
That's what
What do you have to what?
Would you have to multiply by 2 over 2?
Well, you're gonna raise to that power. You're gonna raise to the power of 2/3. So let's watch this, right? Okay, let me switch to red. So my exponent is 3/2, right? Everybody agree? So the reciprocal, remember, that's when you take a fraction and flip it over, right? Right? Everybody's okay with that word? So if I raise both sides to the reciprocal power, watch what happens. So I'm going to raise 216 now to the 2/3 power. And I'm going to do the same thing over here. I'm going to raise this whole thing to the 2/3 power. Oh, I'm so sorry. There we go. So now let's talk about what's going on the left-hand side. The left-hand side is now just 216 to the 2/3. So we just talked about how to evaluate that. I need the cube root of 216, and then I want to square that answer. So does anybody have that? What's the cube root of 216? Jake? There you go. So we're taking the cube root of 216, 6, and now we're going to square that answer. So we get 36 on the left-hand side. Does that make sense? Is everybody with me so far? Okay, so on the left, we have 36. On the right, guys, do you remember what happens when you raise a power to a power? Jake? In this case, they will, but let me just do a side note. If I give you something like x squared to the 3rd, that's really x to the 6th, right? And here's why, x squared, and I'm going to do it 3 times, x squared, x squared, x squared. This is when you add them, when you're multiplying you have multiple bases that are the same, you add the exponents. If you're raising a power to another power, you multiply. So that's how I'm getting x squared, and I'm going to multiply the 2 and the 3, and I end up at the 6. So when you raise a power to another power, you multiply. So one more, if I did x to the 10th and I raised it to the 3rd, that's going to get me x to the 30th, right? I'm just doing 10 times 3. So that's one of your rules of exponents. When you raise a power to a power, you multiply. So using that knowledge, when I come over here to our problem, that's why this works so nicely. The reason why we chose to raise both sides to the 2/3 power is because now 3/2 times 2/3 is just 1. And that'll happen every single time if you raise it to the reciprocal power. Any number times its reciprocal, you're just going to get 1. Oh my gosh. So you mean to tell me that the whole right-hand side that started off so crazy is now just 4m to the first power, or just 4m? That's exactly what I'm telling you. So look how easy this problem just became. Are you kidding? I could do this all day long. I literally do this all day long. But anyway, divide both sides by 4 and I end up at 9. Does that make sense now? Now that you see it? You just need to know that bit about raising both sides to the reciprocal power. Because if you don't have that part, then you're kind of stuck and you're like, I don't have any idea what's going on here. But let's try maybe number 8 together. Oh, good. And 8's got something a little bit different going on. So this one, we have 100 equals 4n to the 2/3 power. There we go. Okay, everybody. What is being raised to the 2/3 power right now? Go ahead, Braylon.
N.
Just n, right? The 4 is not being raised to the 2/3 power, is it? If it were, if I was raising 4n, it'd have to be in parentheses like it was in number 7. I'm just raising the n to the 2/3. The 4 has nothing to do with it. So in a situation like this, where I have something else that's not being raised to that power on the same side, I want to get rid of it first. So if I see this problem, my goal is to get whatever is being raised to the fractional exponent by itself. So what should I do here? Go ahead.
Divide by 4.
Yes, you should absolutely divide both sides by 4 first. Get whatever is being raised to the exponent by itself, and then raise both sides to the reciprocal power. Because if you try to do it right now, then you have to deal with taking the I mean, I guess you could, but who wants to bother? Why you're going to take you're going to mess with the 4 when you don't have to. You're going to make your life harder than it has to be. Don't do that. Let's divide both sides by 4. So I get 25 equals n to the 2/3. Now we're ready to raise both sides to that reciprocal power, which in this case would be, yeah, so I'm going to raise u to the 3/2 power. Same thing on both sides. Golden rule. Whatever you do to one side, you got to do to the other. So now I ask you, what in the world does the left-hand side simplify to? Grace. 125 is correct. Right? Did everybody follow that? So I've got a 2 in the denominator. So I want to do the square root of 25, which is just 5. And then I'm going to cube that value. 5 times 5 times 5 gets me 125. You with me? Everybody's okay? Okay. So I got a 125 on the left. And then on the right, what's that? What's the right-hand side become? Yeah, it's just n. Because 2/3 times 3/2, when I raise that power to the power, it cancels. So I'm just left with n to the first, or n. Yeah.
Because you're taking the square root in this case, because it's even, because you also need the positive or negative.
Good question. Yeah, we're taking the square root.
Because you could have 5, and then 5, and then 5 times negative 5.
So your thought is -5 or -125 could also be an answer? Yeah, you're right. Yeah, you're totally right. So I'm going to add a positive negative in front of there. Right, because anytime we're taking a square root, we want to consider both roots. Thank you. Okay, try another. I thought you'd never ask.
Wait,
Go ahead.
what if it's a negative?
You sure?
Yeah.
It does check. So if you take negative 125 and plug it back in, so the cube root of negative 125 would be a negative 5, but then you're going to square it. And that's how you get a positive 25 times 4. So in this case, it does check. So we would want both roots. Okay, let's try 9. 45 equals 5 times 3k to the 2/3. So I'm going to give you all a moment to just try this one by yourself. Let's see if we can arrive at a common answer. Okay, someone tell me what my first step should be. Cedric?
Divide 5 to the side.
I agree. 5's not being raised to the exponent, so let's get rid of it. Make our lives way easier. Divide by 5, divide by 5. So now I'm looking at 9 equals 3k to the 2/3 power. All right, so now I have the thing being raised to the exponent by itself. In this case, it's all of 3k. So to undo this raising to the 2/3, I'm going to raise it to the 3/2. So I'll raise u to the 3/2, the whole thing, and this one as well. Okay, so on the left, what would 9 to the 3/2 power be? Grace? Yes, would it be positive and negative or no? Yes, positive and negative. Because the square root of 9 is both 3 and negative 3. And then when I cube it, I'm either going to get positive 27 or negative 27. On the right-hand side, those two cancel, so I'm just left with 3k. All right, so now I'm almost done. All I gotta do is divide both sides by 3. So I got a positive and a negative 9. Let's check real quick if that would work. Yeah, I don't see why not. Because we're going to take the cube root. So even if the cube root comes out negative, I'm then going to square my answer. So it's going to turn positive anyway. How do we feel? Okay-ish? Yeah? All right, cool. So the only other thing that I want to talk about today is clearing complex fractions. But lucky for you, I happen to have this little note sheet here with some convenient steps. So let me hand this out to you. We'll try a couple and then I will give you time to work on your assignment. By the way, so tomorrow, this is the last, the clearing complex fractions is the last bit that we are going to cover. That's on your quiz for Friday. So your first quiz is going to be this Friday. So I'm looking at it right now. It's got, so we're solving all different types of equations, linear, rational, quadratic. So you've got a bunch of those. You've got one with exponents. You have an absolute value. And then a radical. And then you're going to have 4 complex fractions to clear. And that's it. Yeah. Goes so fast. Didn't you go already? Oh, no, you waited, right? Oh, that was you. Okay. Yeah, go super fast. Let me hand out these note sheets to you. I need to practice names. I think I've got like a third of those down. There you are. Okay, so let's just take a look-see-loo at the steps here. First of all, you might not even remember what a complex fraction is. It's just a fraction in a fraction, right? Like your worst nightmare. But it's okay, because like most things with fractions, there's easier ways to work with them if you know what to do. So whenever we see fractions inside fractions, these complex fractions, we're going to clear them. Okay, how? So first, you're going to find a common denominator between all of the little fractions in the big fraction. Multiply both the numerator and denominator by that common denominator. And guess what? If you do that step properly, you shouldn't have a complex fraction anymore. So let's see how easy this can turn out. I'm going to again just do it in the notebook so I have it'll be nice and clear in the notes there. So clearing complex fractions. Okay, so the first example is 1/3 plus 3/4 all over 5/6. Okay, so if we follow the handy dandy steps that are right there, number one says find a common denominator between all of the little fractions. So if I look at all of my little fractions and their denominators, I have 3, 4, and 6. Everybody see where I'm finding these numbers from? 3, 4, and 6. So what would the common denominator be for 3, 4, and 6? 12. That's my magic number. I'm just going to multiply the top by 12 and the bottom by 12. Again, if I multiply by 12 over 12, that's just 1. I'm not changing anybody's value. I'm just converting it into a currency I can use. I'm trading that dollar bill for 4 quarters. Same thing, but now I can use it when I go to the vending machine and the bill collector is broken. Okay, so I'm going to multiply the top by 12 and the bottom by 12. Now watch the magic unfold here. Remember that when you are multiplying a whole number by a fraction, well, this is how I do it. You don't have to do it my way, but I think it's so much easier. Take the whole number and divide down first and then multiply by the numerator. So 12 divided by 3 is 4 times 1 is just 4. I do the same thing here when I distribute over here. So I divide down. 12 divided by 4 is 3 times 3 is 9. Oh my gosh. You do it on the bottom. What's 12 times 5? 6. Fast. 10, right? Because you're going to divide down, then multiply by the numerator. So 12 divided by 6 is 2 times 5, 10. Bingo, bango. Oh my gosh. That was not even that bad. And now I could do that. Yeah, all right. I just get 13/10. So all that craziness just gets evaluated into this so much nicer. All right, that's an easy version because that's just all numbers. Let's look at the second example on here because No more just numbers, right? We got some variables in here. So let me copy this one down. I've got x over 9 minus 2 over x all over 1/2 plus 5x over 9. Oopsie. There we are. All right, so take a moment. Don't say anything yet. Just look and see if you can figure out what the magic thing would be that I'm going to multiply everybody by. Don't say it. Just think. And we'll see if we all agree. Do you have the magic? Who can tell me what I'm going to multiply? Katie, go ahead. I agree with you. 18x. Wouldn't that be my common denominator? I'm looking at 9x, 2, and 9. So the numbers get me to 18, and there is an x down there. So I got to multiply by 18x on top and on bottom. Let's try it. So 18x up top. Oh, 18x over 18x. And I'm going to distribute, and I'm going to multiply it throughout the whole thing. So I'll do one, then you do one. So let's see if we match. So when I go to distribute 18x and I'm going to multiply it by x over 9, I'm going to divide down, multiply up. So if I do 18x divided by 9, that's 2x times the numerator, 2x times x. Isn't that 2x squared? Yes. Now you try the next one. Do 18x times the, it's going to be a minus, right? So do 18x times 2 over x. Divide down, multiply up. What number goes there? DJ? 36. Did you get 36? Let me show you where it's coming from. You're going to take 18x, divide by the denominator. If you do 18x divided by x, the x's go away. So my only answer, when I divide down, I get 18. Now take 18 and times it by the numerator, 36. That's where it came from. So now I'm going to do the same thing down in the denominator. I'm going to do 18x. I'm going to divide it by 2, multiply by 1. So think what's 18x divided by 2 is 9x times 1 is just 9x, right? So downstairs I get 9x. And then do the same thing, do 18x times 5x over 9. Divide down, multiply up. That's not the only way to do it, but I'll tell you it's the easiest way to do it. If you do the division first and then multiply, you keep your number so much smaller, everything, and you can do it in your head, usually. So it's going to be positive. What goes here? Anybody have it? 10x squared, you say. I agree. Do you see where that's coming from, everybody? If you divide down, 18x divided by 9 would be 2x. So now I do 2x times 5x. That's where I get 10x squared. Awesome. So there is that. And then I would just check and see if this could be simplified any further. And I don't think it can. I could take an x out of the denominator, but since it doesn't reduce with anything in the numerator, like I can't take an x out of the numerator also. I could take a 2 out of the numerator, but it's not going to cancel with anything in the denominator, right? I can't take a 2 out of the denominator also. So I don't think I can go any further than that. You could factor the numerator and factor the denominator, but if nothing cancels, you don't have to bother. If something were going to cancel, I'd have to, but I think this time we got lucky. You with me? All right. You want to try the third one? Oh, that one's kind of, I'll help you get started. Well, try it on your own if you think you know what to do. If you're totally lost, I'll help you get started. All right, I got to flip the page though. I will say there's not nearly enough room to do it on the sheet. So I would give yourself some space. You know how that's like the mantra of COVID is to like give yourself some grace? I say you need to also give yourself some space to do your math. You can't crowd it all in there. It's too much. (16 over x minus 1). Okay. Holy baloney. I'm looking at these denominators. I'm going to have a heck of a common denominator here. This one's just not nice, right? There's not like, oh, just multiply everything by 7 and it'll be fine. Not this time. So I am going to have, looks like I got to do at least these two match, x minus 1 and x minus 1. So it looks like, would you agree with the common denominator being 16 times x minus 1 times x plus 5? Yeah, it's a lot, but you know what? So am I. So there we go. Let's put that in there. We got 16 times x minus 1 times x plus 5. This one's going to be a bit much, but there you have it. Sometimes that's the way the cookie crumbles, right? Okay, so let's walk through this together. Oh, and I'm multiplying by the whole numerator and the whole denominator. Okay, cool. All right, ready? So when I divide down and multiply up, the 16s are going to cancel out. So then in the numerator, wouldn't I have x squared times x minus 1 times x plus 5? I will have to do this out, but I'm not going to do it just yet. There's that first bit. Oh, I probably should have done it over here and kind of kept going this way. I'll rewrite it over here. So there's my first chunk, x squared, x minus 1, x plus 5. My next chunk, okay, watch. I'm going to take all of this and I'm going to divide down. So the x minus 1s are going to cancel each other out. So then I'm going to have this x squared times 16 and times an x plus 5. You with me so far? I know there's a lot going on here. So I am going to have to subtract the whole thing. So what'll be left? I'll have x squared times the 16 times the x plus 5. Oh, I'm so sorry. There we go. Okay, don't worry about doing all the multiplication out just yet. Let's just get the fraction cleared first. Okay, now downstairs, I'm going to try the same thing. Let me get rid of this because I moved it over. All right, so now I'm downstairs. I'm going to divide down. The x plus 5s are going to cancel out. So now I'll just have 16 times x minus 1 times another x minus 1. So let's write that. I'll have 16 times x minus 1 times another x minus 1. Now you try this last bit if you haven't yet already. You try. What am I going to get when I multiply this big old mess times that? What happens? You got something? Cedric, what do you put here? 16 times 16 times x plus 5. I agree. The x minus 1s are going to cancel. So you'll have 16 times x plus 5 times another 16 that's already in the numerator. Perfect. All right, so now the fraction is cleared. And now, yeah, they're not normally this bad. This one just happens to be a particularly hellacious one. I don't think there's none on your homework that are this bad. And I don't think that there's any on the quiz that are this messy. But yeah, now you're gonna want to multiply all this through, subtract, and sort of simplify, because there could be stuff that cancels. So let's just see. It doesn't have to be too bad. So I would get x cubed minus x squared if I multiplied those first two, and now I'll FOIL it with this one. So that's x to the fourth plus 5x to the third. Insides would be a minus x to the third. And then the last would be a minus 5x squared. Five x to the third squared. Yep, that's fine. Right? I feel, why are they, I feel like they should all be a different degree though. X to the fourth, 5x cubed. No, that's right. Okay. All right. Now over here, that's just 16x squared times x plus 5. So I can do that. So that would be 16x to the third. What's 16 times 5? 80? So that's going to be, what is it? Okay, so that would be a positive 80x squared. But remember, I have to subtract the whole thing. So I'm really going to have a minus 16x cubed minus 80x squared. So there is my whole numerator. And now I can combine like terms. But you know what? I'm going to do that in the next step. Let me do the whole bottom, and then I'll do another step where I combine like terms. So downstairs, that's just x squared minus 1 times 16. So that'll be 16x squared minus 16. That wasn't so bad. What's 16 times 16? Is that 256? It is 256 times x plus 5. So that would be a positive 256x. And I don't know what 256 times 5 is. $256 times 5 is 1280. And now all I have to do is combine like terms, and I might be done. So up top, x to the fourth, I've got where are you looking? Here?
No, on the bottom, because you did x, yeah, because you did x, well, x minus 1 times x plus 1, wouldn't it be like x in the middle of 16x squared?
Oh, you're right. I did x minus 1 times x plus 1 because I'm a silly goose. You're totally right. That would be x squared minus 2x plus 1. So I'd have to do 16x squared minus 32x plus 16. Oh, thank you for catching that. Minus 32x plus 16. Yes. Oh boy, I would have been so mad if I got this far and I messed up on that one stupid little thing. Thank you. Okay, so up top, let's see, I've got 4 minus 16 would be a negative 12 x to the third. And then negative 85 x squared. Tell me if you agree. You with me? And then on the bottom, what do I have left? I've got a 16x squared, and then x is 256 minus 32. What's that? 224. So we'd have a positive 224x. And then 1280 and 16 is just going to be 1296. And I think we're done. On top, yes, you could factor out an x squared, but since I can't factor an x out of the denominator, they wouldn't cancel with each other anyway, so I don't have to bother. I'm done. So yes, that one's an absolute nightmare. That I might give you as like a bonus, maybe. Yes.
So in the original one, you have an x minus one on the top and x minus
Right here, these two?
Yeah.
No. The only way to do that is if all four of them had it. So like, for example, if you had, let's just do a simpler version. If you had like 2x plus 3 over 4x plus 5, you can't cancel those x's because they're part of a binomial. You'd have to be, you could do it if you had something like this. Let's say I was able to factor out an x from there and I had to factor it out an x from there. Because now I've taken it out of the binomial, now those could cancel. But so you know what I mean? So both of these terms would have had to have had that x minus 1 for me to pull it out. And if I could do the same on the bottom, that's when I could do that. Good question though. Okay, I think that's a good place to put a pin in it for today. Your homework this evening, if you go back to this same sheet from yesterday, I just want you to do the backside, 11 to 18. And they're not nearly as bad as the one we just did. Everybody has the sheet, right? You didn't lose it yet? Okay, 11 to 18, right here. These are the ones, I'll just put it on the video if anybody in internet land is watching. There's the first 4. And there's the bottom 4. Okay, cool. So tomorrow, we will go over this homework. We will, tomorrow's Thursday, right? Yes, I have a little activity for us to review for our quiz. I'll answer any questions you could possibly have. And then we'll take that quiz on Friday and it'll be the weekend again. Yes. Does anybody have any questions right now? All right, so give these ones a try. I am going to, what am I gonna do? I don't even know. I'm gonna upload your notes. Oh, and I'll make this live on Jupyter so you can submit it when you're done.